Today we are going to attempt the titration question from May-June 2022, variant 4.1. And the question is basically the question number 4. So let's go back to the question number 4 straight away. So this is the question. Now I'm reading the question from the paper. It states that the student determines the concentration of sodium hydroxide. They need to determine or calculate or find out when it reacts with the citric acid, which is C6H8O7. Now, how the concentration need to be calculated, you need not to be bothered about that because they're going to guide you step by step. Now, after that, they have given you the process. These are given in the form of 9 steps. So I'm reading down all the process steps here. Number 1, the student, step number 1, records the mass of an empty beaker, and then he adds a solid citric acid to it. Now, how much amount of citric acid is given to him? Whatever the amount is given, he is going to add it to the beaker and reweigh it. So the first step is he is measuring the mass of an empty beaker. First of all, he's measuring the mass of an empty beaker. And the second step is that he's adding the solid citric acid to the same one. So he has a beaker plus the amount of citric acid present in it, right? So when you will be subtracting both the masses, so you'll be getting the mass of citric acid there, right? So you'll be getting the mass of citric acid there. Coming to the step 2, when we move on to the step 2, now if he says that record the mass of the beaker and the citric acid. So for previously it was empty beaker, then he added the solid citric acid to it, and now mass of the beaker with the citric acid. So when you subtract both the masses of empty and the mass of the beaker with the citrics, he'll be getting the mass of citric acid there. Coming to the third step, he adds a distilled water to the beaker and stir the mixture until all the citric acid dissolved. So what is he doing? He's making a saturated solution. He's making a saturated solution of citric acid. So what he's doing and how much water is he making? So that is mentioned in the next step, that is 250 cm cube. He is adding water to it, and the procedure need to be done in the volumetric flask. So volumetric flask is this apparatus in which we prepare a saturated solution. So he will be adding whatever the beaker contains the citric acid. He'll add a little amount of water, approximately 100 cm cube. He'll shake and stir and properly dissolve all the content to it, and he will be pouring it back into the volumetric flask, whose capacity is 250 cm cube. Then what he'll do, the same beaker, he'll be adding little more water and thoroughly rinse it properly, and he is going to shake so that whatever the solid particles are left which remain insoluble, they're also transferred into volumetric flask. And then what he'll do, their volumetric flask of 250 cm cube will be having a marking. Now this marking means that when we will be pouring water up till this mark, then this capacity is going to be approximately 250 cm cube. So he will be, after adding all the content, the solution he made with the 100 cm cube or 50, then he is going to add little more in order to rinse all the solid particle back into it. Then what is he going to do in the third step? He is going to add the water up till this mark, and then he is going to add a stopper to it and shake it thoroughly. This is going to give him a uniform solution, standard solution of 250 cm cube. So we need an apparatus for that in order to make the saturated solution, and that is basically a volumetric flask, right? Remember, the saturated solution are made in the volumetric flask, not in any other kind of flask, because they have got a marking. And if the water is filled up till that particular mass, we're able to make that specific volume of saturated solution. Now coming to the step 5, fill the volumetric flask up to the mark with the distilled water. As I've already explained, shake the flask to make the solution P. So here they are making solution P, which is basically my citric acid's saturated solution. Citric acid saturated solution. Okay. Now, after doing this, what he does it in step 6, out of this 250 cm cube saturated solution, he is just going to draw 25 cm cube of V into the conical flask. Now, how you going to draw it? He is going to pipette out. He is going to use the apparatus that is pipette. Using the pipette, he'll put the pipette in this volumetric flask, and using the pipette filler, which is a safety precaution for sucking the chemical into the pipette. So using the pipette filler, he is going to draw 25 cm cube and he is going to pour it into the conical flask. Conical flask is a flask where we place the chemicals, we mix the chemicals, and that is all, right? Now, then what he'll be doing, he'll be adding a few drops of indicator. Now, because both the solutions, whether you talk about an alkali, which is your NaOH, or you talk about the citric acid, right? They both are basically colorless nature. So when we have the colorless solutions during the titration, we will not get to know when exactly the acid or H positive ion are being completely neutralized by OH ions from an alkali. So when they both are colorless solutions, when the alkali and an acid, we always use a indicator, a suitable indicator. A suitable indicator, we'll just add 1 or 2 drops of indicator into the conical flask along with 25 cm cube of my citric acid, right? Citric acid. Now, after that, he fills the burette with the sodium hydroxide and he prepare the burette by washing it thoroughly. What he washes it with? He first washes it is with distilled water, and secondly, he washes it with the chemical which he's supposed to pour into it. Now, why he need to wash the burette? That's something very important. Maybe this particular apparatus which was used in the previous experiment by some other student, that student has filled acid into it. So maybe by chance this burette was not washed after that experiment. So it's student's responsibility to wash his apparatus thoroughly in order to get the accurate results. So what do we do? How do we wash the burette? We first of all wash it by a distilled water, and then, because distilled water are going to leave some of the drops of water or traces into the burette. So if we fill in the chemical into it, that's going to dilute that chemicals and we will again not get the accurate result. So the first washing is with the distilled water, and secondly, in order to remove these water drops from it, what we do is we wash this whole burette back again with the chemical we are supposed to fill in it with. So whatever the NaOH you're going to fill in it, so you are going to add NaOH and you will let that NaOH run out into the sink. That is basically how we wash the burette. First with the distilled water, and secondly with the chemical we need to fill it in, right? And the third time we are going to fill it this again with the same NaOH in order to perform the titration. So this is very important, how to wash a burette. Whereas a conical flask, we just wash it with the water. That's it, right? So our apparatus should be very clean. They should be properly thoroughly washed, dry and clean in order to get the accurate results. Now that is what we have done in step 8. We have taken the NaOH in our burette and we recorded the initial volume. Okay, the mark, the up till the mark we have filled the burette. Now after that, step 9, add NaOH into the flask until the indicator changes the color. Then what we are going to do is we are going to keep a white tile under the conical flask so that even the smallest change of color is being observed by us. And then what we'll do is we'll open this tab of the burette and we are going to drop one by one drop at a time into the conical flask. Make sure that the drops don't fall out of the conical flask or are on the walls of the conical flask. Again, we can't waste the chemical, otherwise the calculations will be affected. So it should directly fall into the conical flask, into the chemical, and you keep on swirling the conical flask, keep on moving so that both the chemicals thoroughly mix down. Then student repeat the step 6 and 9 3 more times. So we will be performing the same titration with the same chemicals 3 times in order to have the accuracy in results, because 3 readings we will be taking the average of those readings in order to have an accuracy. The student, now coming to the this is the whole procedure. We should be very careful while performing this procedure. Coming to this part A of the question. The student uses the incorrect piece of the apparatus to measure the volume, right? So what is that incorrect piece of apparatus? Let's go back and see, we check it out. What was the incorrect piece? Now look here, what we did was he added, okay, here's the incorrect piece. Now look here. Use a measuring cylinder. Do you think we should be measuring using the measuring cylinder in order to measure 25 cm cube of P? So measuring cylinder is a cylinder which give us an inaccurate volume, right? This give you approximate volume. This give you an approximate. If you want an accurate volume exactly of 25 cm cube, I've already suggested we'll be taking the pipette over here. So measuring cylinder is for the approximate volume. It never gives you the accurate volume. So that was an incorrect piece of apparatus which we have used here. The student used the incorrect piece of apparatus to measure the volume. So that was basically identify the incorrect piece of apparatus suggested and suggest a more accurate piece. So the incorrect piece was basically your measuring cylinder, right? And your accurate piece for the fixed 25 cm cube, we suggest that we will be taking pipette along with the pipette filler, which is a precautionary apparatus or tool, and so that the chemical is not sucked into our mouth by mistake. Coming to the part B, explain why the content of the volumetric flask are shaken in the step 5 in order to have a uniform solutions, in order to have uniform or evenly distributed solutions. Okay? If you don't do it, distributed. If you don't do this, if you don't shake the chemicals properly, thoroughly, so there might be the more concentrated solution at one level, there might be less concentrated solution at some other different level. So we need to have a uniform solution. Explain why the indicator is needed in the step 9. In step 9, we are adding indicator. I've already explained you. So indicator is a chemical which is actually which tell us which changes the color when the complete neutralization take place. When the complete neutralization, that means when the all the neutralization take place, when all the OH ions are being neutralized by when all the OH ions are neutralized by H positive ions. So this is the indicator. Indicator basically change the color to show that the reaction has ended, So when the reaction will end, when all the OH ions are neutralized by the H positive ion, when the complete neutralization will take place. So indicator at that time, it's going to change color, right? Which is again going to indicate that the reaction has ended. So this is what we will be writing it down, right? Further moving ahead. Now coming to the D part of the question. Now here the diagram shows the masses on the electronic balance, right? So it's an empty beaker here. We have an empty beaker here. So empty beaker is actually weighing your 45.36, and this is a beaker with the citric acid. This is a beaker with the citric acid, and it's basically weighing 50.32. Now, what will be the mass of the citric acid added to the beaker? What we will do here, we will be subtracting the mass of a beaker with the citric acid, and from this we will be subtracting the mass of an empty beaker, and whatever the difference we'll have, that will be the difference. That difference will be basically the mass of your chemical or mass of the citric acid you are adding to it. Okay. So this value basically is when you subtract both the values, so we will be getting the answer, that's 4.96. So 4.96 is a mass of our citric acid which is being given to us, right? So this is the mass of citric acid. Going ahead. Okay, so we write down here 4. 0.96 grams. Now calculate the number of moles of citric acid added to the water. So this is the mass which we have added. So we have to convert this into moles. So the formula for calculating the moles equals to mass divided by its MR. So mass is 4.96 and the MR which is given to us in the question here, that's 192. So when we'll divide these value, we'll be getting the number of moles. So number of moles on computing this, we'll be getting 0.0258 moles, right? Now they're saying that 0.258 moles. Okay. Now what we have done in the previous step, we have whatever the mass of citric acid was given to us, that mass we have dissolved we have dissolved that in 250 cm cube, right? So now in the next step, F part, they're asking us calculate what is the concentration in mole per dm cube. So we know the number of moles which are present in 250. So 250 cm cube, that has 0.0258 moles. So we can easily calculate for 1000 cm cube. We need to have both the units same. So 1 dm cube being converted into cm cube, that makes 1000. So 1000 cm cube will have X value, right? X number of moles. So that will be 0.0258 divided by 250 multiplied by 1000. When you simplify it, it's basically 4. So whatever the number of moles that you divide by, that you multiply by 4 and you will have the answer. So the answer on computing, we will be getting the answer, the molar concentration of the substance of the citric acid will be 0.103 moles per dm cube. So this is basically the concentration of citric acid. Going further, let's see what is the next part of the question. Okay, we have the G part over here. Now in this G part, the diagram shows a part of a burette with the liquid levels at the beginning and at the end of the titration. So this is the initial reading of the burette and this is the final reading of the burette. And as I've already told you in the previous videos, that we always read the burette upside down. So when we'll read the initial, so we'll be getting, this is for 4.1 and 4.2. So the initial will be 4.2 here. And the final is going to be, when we read it, it's going to be basically 35.1, 35.2, 35.3, 0.4, 0.5, 0.6, and 0.7. So this is basically 35.7. I'm sorry, not here. That is the final burette reading. So we'll be writing 35.7 here, right? And when you subtract both the values, we will be getting the volume of NaOH, which has been used to titrate, to neutralize your citric acid. So when you will do the subtraction, we will be getting the answer, that's basically 31.5, right? Now the next part is they are completely filled. The second titration is all done. Third titration is all done. Fourth titration is all filled. Now remember to always, this is a blunder which normally the students make. Now if the value, if the reading, the initial reading of the burette is at 0, don't write down just 0. Always write it down up till 1 decimal place. Otherwise the examiner will deduct the marks, because between 0 and 1 there are 10 divisions here, right? So each division is basically, the first division is 0.0, the next will be 0.1. So you have to write down whatever the values you're writing, you have to write it down up till 1 decimal place. So the initial value, if it is at 0, so that means it's 0.0. Coming to the next part, they're asking you to tick the best titrations. We have got 4 titrations here and they're asking us to tick the best. Now the best titrations are those titrations which have a difference of, which have the difference of 0.2 or less than 0.2 or equal to 0.2. So let's see which all have a difference of 0.2, 30.9, 30.7, 30.8. These are going to be my best titration. But because this is 31.5, this is far more than 0.2. So this is definitely not going to be considered as the best titration. So I'll not put a tick under this first titration, right? So this is what we'll be writing it down in. They're demanding getting the answer, the same answer in explanation. So the table all show the result of the 3 other titration. Complete the table that we have already put a tick here. Explain why you have ticked these values, and you have to explain here. So we are putting the experiment. We are putting the tick under the experiment 2, 3, and 4. The reason is they have a difference of less than or equals to 0.2. Okay, so they are supposed to be your best iteration results. Moving ahead, going to the next part. Now they are asking us use the best iteration results and calculate the average. So our best iteration results, we'll see what were the best iteration results above. So our best iteration results are basically 30.9, 30.9, and we have 30.7, and we have 30.8. So these are the 3 best iterations. So we have to calculate the average. So 3 values divided by 3. And when divided by 3, we get the answer. That's 30. This is 30.8. So we'll be getting the answer 30.8, right? Now, use your answer in F. Calculate the number of moles of citric acid in 25 cm cube. So we need to find out the number of moles which are present in 25 cm cube. They're asking us to find out the amount of moles present in 25. So we know the number of moles which are present in 250. So if 250 has these many number of moles, so 25 will have how many? So on that basis, we have 250 have 0.0258. Let's go back to that particular part of the question. So here. So it says that find out, calculate the number of moles of citric acid in 25 cm cube. So 250 cm cube has 0. How much was that? 0.0258. So 250 had 0.0258. 0.0258. So 25 cm cube will have 0.00258 moles, right? So you'll divide this value by, basically, you'll divide it by 10. Now, the equation for the reaction between citric acid and NaOH is shown over here. Now, when we have a look at the equation, we basically look it for the molar ratio. Now, these are the 2 chemicals we are reacting together, and they are reacting in the ratio 1:3. Now, calculate the number of moles of NaOH that react with the citric acid in 25 cm cube of solution. So, number of moles of NaOH which are reacting with 25 cm cube. So, we can see here there is a molar ratio 1:3. So what we will do is कि अब आपको यहाँ पर जो भी moles आप citric acid के use कर रहे हैं उसके 3 times आपके पास moles जो होंगे वो आपके NaOH के होंगे. तो हमारे पास moles जो हैं वो citric acid के कितने हैं? These are the moles which are of citric acid. They are basically 0.00258. So NaOH के जो moles होंगे वो 3 times होंगे. So the moles of NaOH will be 0.00258 times 3, which are reacting with 25 cm cube. So according, when you compute this, you will be getting the answer 0.00775 moles. Okay. So when the 2 chemicals react together, they react together, either they will be giving you the molar ratio or they will be giving you the equation. On that basis, unke molar ratio dekhkar, you will be finding out how many moles of the other chemicals you'll be using in order to for the complete neutralization. Okay. Now here they know that 25 cm cube has got these many moles. So all right, so let's do the M part of the question. Now it says that 25 cm cube of an NaOH is added to an excess of iron sulfate. Now we already know the concentration. So this concentration is in 1000 cm cube. So we can write down कि 1000 cm cube has, they're asking you that how many moles, because further when you see that they're saying a precipitate is being formed. The precipitate means that solid component, solid product has been formed. So this is basically the precipitate form. Now let's see, use the equation and your answer from L to calculate the number of moles of FeOH whole twice that is being made. And they're giving you a hint that you have to use the answer from L. So in the L, they have given you the concentration of NaOH. So we have 0.252 moles which are present in 1000 cm cube. So 25 cm cube will have 1000 cm cube. So 25 cm cube will basically have 0.252 divided by 1000 into 25. We have a shortcut for this, that is basically moles. Formula, moles equal to concentration divided by 1000 into volume. So using this particular formula, again we'll have the same relation. Now when you will compute this particular value, you will be getting that in 25 cm cube you have got how many moles? You have got the number of moles, basically that is 0.0063. So these are the moles of NaOH, okay, which are present in 25 cm cube. Now they're asking you to calculate, the amount of being precipitate being formed. Calculate the number of moles of FeOH solid that is being formed. So for this, we again have to refer to the molar ratio. Now look here, they're reacting in the ratio of 2 is to 1 is to 1 is to 1. So if this is 2 moles, they're getting 1 mole of iron hydroxide. So 25 cm cube of NaOH is 0.063. So half of this will be basically the moles for FeOH. So half of this is basically your 0.00315. So these are going to be the moles of your FeOH whole twice or iron 2 hydroxide. Now we already know that iron 2 hydroxide, they're asking you the color of this precipitate. This is going to be green in color, right? Let's see what else they have. And that is the end of question. And this question was for 18 marks. I hope it is clear.